Hi there and welcome again to the Python-verse series. This is video number 13 and today we are going to talk about a very interesting topic called as sets. I think most of us have studied about sets in the junior classes. We all know what sets are. So this video is going to be an interesting one because we all of us already know what sets are. It's just that we have to explore how exactly we can initialize the sets in Python, how exactly does this data structure look like, and what are the different properties, what are the different operations which are available on this data structure. So yeah, let's get started. So what are sets? Just to revise, set is any unique collection of objects. So all the objects in a set, they have to be unique, and examples could be like first n natural numbers. Like here I have written first 10 natural numbers, for example, so 1 2 3 4 5 6 7 8 9 and 10. And similarly a set of days, it could be a set of, let's say, vowels, set of consonants, set of the first n prime numbers. And similarly we can have a set of any type of entities. The only condition is that they have to be unique. So we cannot have a set like, for example, if I want to, so this is not a valid set because not all the elements are unique. One is repeating here, so this is not a valid set. So for this data structure to be called a valid set, we will have to have all the unique entities in it, right? Okay, now before we talk about the syntax of sets in Python, let's just understand the use of different types of brackets. This is just for the sake of, let's say, I would say that this can be kept in mind. So because this really helps us to grab the syntax very easily. So there are 4 types of brackets which are there on the keyboard, which are known to all of us. And the square brackets, they are used for a list data structure in Python that we already know because we have talked about the list in the previous videos. And similarly, dictionary uses the curly brackets that also we have seen in the previous videos, right? Now in this video we will see that we can use curly brackets with the set data structure as well. So we can see that the curly brackets are being overloaded because we are using them with both dictionary and the set, but the way we are using them is slightly different in both the cases. Now the other one is tuple. We are still to cover what a tuple data type is. We will cover it in a future video, but for now what we can think of is that we'll be using the parentheses in case of the tuple, right? So all the types of brackets, they are having their use in Python. That is what I wanted to tell, and this really helps us to recall things later when we are writing the code and thinking of the syntax. It basically helps us easily build new neural networks in the brain. So like this is just a I can't call it a concept. It is just a technique to keep things in mind. That's all. Cool. Now before I go on and talk about initializing, okay, I did some cheating and I have been caught. I should write initializing a set in Python. I mean, I did some copy paste, not exactly cheating. Cool. So before we go ahead and talk about initializing a set in Python, well, I wanted to make a small request. If you're liking these videos, I request that you subscribe to the channel and click on the bell icon, because when you subscribe to the channel, it really helps others to find this channel out. And this really helps me and supports me in creating more and more videos. So yeah, now let's go ahead and let's learn about initializing a set in Python. Now there are 2 techniques which we are going to talk about. One being with the use of curly braces, as we can see here. So let me just do one thing. Let me just clear this, and we can just open a Python terminal, Python shell, which we are all aware of by now. So let me just show you. So here we go, set 1 is this. Now if I check the type of set 1, I can see that this is class set. So which means that 1 is a variable of type set. Similarly, I can initialize set 2, and yeah, a similar way I can check the type of set 2. And we learned a technique. So if we are given a variable and we want to see what all operations are supported, what all functions are there which are supported by that variable, then there is a function which we can use, that is dir. So let's see what does dir of set2 gives us. Cool. So as we can see that these are all the functions which are supported, like add and clear, copy, difference, difference update, and so on. So these are the different operations which are supported. I'll be giving examples of some of these in this video only. So yeah. The other way of initializing a set is using the set function, wherein we are passing a list of elements and they're converted to a set. So for example, if I say set1 equals, let's say set, then as arguments to this function, I'm passing a list wherein I'm writing 1, 2, and 3. Now if I check the type of set1, I can see that this is a set. So these are the two ways of initializing a set. Now let's talk about the operations on a set, operations on sets basically. Now one is the union operation, which basically returns a new set that contains all the elements that are in either set or in both the sets. So let's say we have 1, 2, 3 in set 1 and 3, 4, 5 in set 2. Now if we do a union, we will get a third set which contains the elements which are present in either set 1 or set 2 or in both of them. So if you will see that on doing the union of set 1 and set 2, we will get 1, 2, 3, 4 and 5. So if you see that 3 is present in both of them, but in the union we will get it only once, because for a set to be valid, it has to have all the unique elements. So let's try this out. We already have set 1 and set 2 in our workspace. So set 1 is there, set 2 is there. So let us just try set1 dot union. Let's pass set 2. Now you can see that in this specific case, like in the union operation, even if I do set2 union set1, then also I will be getting the same results. I think in typical mathematical terms, this property is called as associativity. So which means that the union, like union of sets is associative. You can do A union B or B union A, you will be getting the same results. Now if we talk about, so yeah, union can also be expressed by this symbol. If I do this like set1 set2, I will still get the same results. So like this operator is also used for the bitwise OR. We will talk about bitwise operators in some future video, but for now we have seen that this can be used for union of two sets. Coming to the next operation, that is intersection. So what exactly does intersection returns? Well, it basically returns a new set that contains only the elements that are common to both the sets, right? So set 1, 1, 2, 3, set 2, 3, 4, 5. As we can see that there is just one common element. Let me just add one more common element to make it a little interesting. Now let me just do the copy paste. So set 1 is 1, 2, 3. Set 2 is 2, 3, 4, 5, right? Now if we do set 1 intersection set 2, we get 2 and 3. That is both the common elements. So this function can also be used, but I'm just using this shorthand to keep things simpler for me. Then comes the next operation, that is the difference operation. It returns a new set that contains only the elements that are present in first set but not in the second set. Now this is interesting because this operation will be giving different results depending upon which set comes first. Let me show you some examples. So let's say we have 1, 2, 3 and we have 3, 4, 5. Cool. But let me see what exactly do we have in our workspace. We have set 1 as 1, 2, 3. Then set 2 is 2, 3, 4, 5. Now let's try set 1 minus set 2, which means all the elements which are present in this set 1 and which are not present in set 2. Let's see what the result is. So we can see 1. So 1 is the only element here which is present in this set but which is not present in set 2. If we talk about 2 and 3, 2 and 3 are present in set 2 as well. Similarly, in this example, if you see 1, 2 are the only element which are present in set 1 but not present in set 2. So when you do a difference, it basically gives us all the elements present in set A which are not present in set B. Now let me do the reverse of it. What if I do set 2 minus set 1? I get 4 and 5, which means all the elements which are present in set 2 but which are not present in set 1. So this shows us that difference operation on sets is not associative, which means if you do A minus B, the result will be different than if you do B minus A. Of course, there can be exceptions depending upon the kind of set which is given to you, but this is the general rule. Cool. Now, yes, let's move on to the next operation, that is symmetric difference. So symmetric difference basically returns a new set that contains only the elements that are present in either set, but not in both the sets. So what it does is that it returns a new set which contains the unique elements from both the sets. Meaning, if let's say some element is present in both the sets, then it is not included as the part of the symmetric difference. So let's look at some examples. Let me just copy paste this set only. So set 1 is 1, 2, 3 and set 2 is 3, 4, 5. So let's try to do set 1 and symmetric difference set 2. So what we get? We get 1, 2 and we get 4 and 5. We do not get 3 because that is the common element in both the sets. So we get the symmetric difference. This is the idea behind symmetric difference, right? Cool. Okay, so the next topic which we have to discuss is typecasting between list and set. So we have seen a tutorial on typecasting, but we only talked about the primitive values. Like here we are going to talk about, I think for the first time we are going to talk about typecasting of data containers, because this list and the set, they are data containers, right? So let's see. So I have created a list called as twins. Let me just write it down here. So now we have twins. If I check type of twins, you will see that it is a list, right? Now we are going to convert it into a set. So the idea is like how exactly we do typecasting. It's similar to the way we do it in the case of primitive types. We just have to use the set function, just like we used to use a function like int or float in case of primitives. Here also we have to use the set function. So let's just do it. So unique is equal to set of twins. Now if you will see unique, so uniques now is a set, and if I check the type of uniques, it will be a set. So as you can see that like all the duplicates have been removed. So this is also a simple hack in Python. In case you have to remove the duplicate values, you can always use a set. Then yeah, print uniques is done, type uniques is done. Now let's try the other way around. Let's say we have to create twins list, twins as a list. Let's see whether what kind of list shall we get back. So I'm calling list function on uniques. Now let's see what do we get in twins list. So we get a list data structure that we can check with the help of type, or the brackets are also revealing that. If we do a twins list, we see that this is a list, but as you can see that when we were converting from a set to a list, all the duplicates were lost, but they don't come back even when you do the reverse type conversion. But yeah, so this is a good technique. Whenever you have to remove duplicates out of a list in Python, you can always take the help of sets. So I hope you learned about sets in this video and all the different operations which we performed on sets. And that's it for this video. I hope you enjoyed. I'll see you in the next set of videos. Thanks a lot for watching, and bye-bye.